This recording is on Unit 3, titled Discrete Probability Distributions. It says it can simply be put as probability models for numerical discrete values. So it continues by saying that discrete probability distributions are numerical probability models for random variables. The variable has a finite or countable number of values. It continues to say the random variable, and it highlights the term random variable because we have a new word added to variable called random, is a numerical variable whose value depends on chance. The important point here is that the variable is numerical. It can be discrete or continuous. However, there's another very important point, that its value depends on a probability value. Okay? And I think that's why it has the name random, because its value depends on chance. It may or it may not happen. According to say, we will only be dealing with discrete random variables, that's countable variables. Random variables are denoted using letters such as X, Y, S, etc. So now, discrete random variable can have certain distinct values, for example, 1, 2, 3, 4, 5, or 6 in the case of throwing a dice. So therefore now, that one, when you throw a dice, there's a probability of getting a 1. There's a chance that you may get a 2 or 4 or 3 or 5 or 6. So that's why it's called a random variable. You're not certain to get a 2 anytime you throw the dice. Okay. So there's that uncertainty associated with random variables. Now, a probability histogram is a bar chart which the horizontal axis corresponds to the value of the random variable, and the vertical axis corresponds to the probability of each value of the random variable. So let's take a look at example 3.3. It says here there's a discrete random variable called Z that has the following probability distribution. So Z can assume only 3 values, 1, 2, or 3. Okay, because bear in mind, all the probabilities on a probability distribution must add up to exactly 1. Okay, so any value that you do not see on this table, Z cannot assume it. For example, it is impossible for Z to be 5. According to this table, it is impossible for Z to be 4, 0, or any other value other than 1, 2, or 3. Okay, so it says where M is constant. It says find the value of M, find P of Z more than or equal to 2, find P of Z less than 3. So let's find the value of M. We know that the sum of the probabilities on any probability distribution must add up to 1. So therefore, M plus 4 plus 2M is equal to 1. So here we have an equation constructed with the M in it, only one equation, one variable suffice. One variable, one equation suffice to solve it. So we can solve for M by adding 1M plus 4M, that's 5M plus 2M, that's 7M is equal to 1. So therefore, M must be equal to 1 over 7. So M is 1 over 7, 4M is 4 over 7, that's 4 times 1 over 7. And 2M is 2 times 1 over 7, which is 2 over 7. So now we can find the probability that the Z is greater than or equal to 2. At least 2 or 3. So we simply add 4 over 7 and 2 over 7. Bear in mind, when we use the word or, we are referring to addition. 2 or 3. Okay, so we add 4 over 7 plus 2 over 7. That will give us 6 over 7. And less than 3 means 2 or 1. Okay, 3 is not included. In that direction, after 3, we get in 2 and then 1. So less than 3 implies we've got to add 4 over 7 plus 1 over 7. That will give us 5 over 7. So please take note, in probability analysis, the word or implies that we've got to add and the word and implies that you've got to times. Okay. Leisurely, I said 4/7 and 2/7 because in arithmetic and is plus. So when I say 4/7 and 2/7, I'm speaking in terms of arithmetic. So therefore, we can add 4/7 plus 2/7. And analyzing probability wise, that would be P of Z equal 2 or P of Z equal 3. Okay, so that's 4/7 and 2/7. So here and is being used arithmetically. So that's why it's plus also like the word or.